So in this video we are going to discuss how to find a number of zeros in a particular expression. So the question can be in a form where you are given a complex expression and you have to find how many zeros will be in that in the value when that expression is solved, right? So for example, let's say we are given an expression 24 into 32 into 17 into 23 into 19, and we have to find how many zeros are in this expression when this will be solved. Similarly, we can have another question. Right, so we have to find what's the number of zeros in both of these expressions. So what do we mean by the number of zeros, and how do we obtain the number of zeros? So if I multiply 25 by 4, how many zeros I get? I get 2 0, right? If I multiply 5 by 2, I get only 1 0. If I multiply 15 by 2, I get only 1 0. Why is this happening? Because to get 1 0, we need a pair of a 2 and a 5. So a pair of 2 and a 5 will give us 1 0, right? So in this case, this can be represented as 5 square into 2 square, right? So we have two pair of 5 and 2, right? So that's why we will get 2 zeros. In this case, we only have one pair of 5 and 2, which can only yield us 1 0. Similarly, in this case, 15 can be represented as 3 into 5 into 2. So again, we have only one pair of 5 and 2, so I'll only get 1 0, right? So in order to get 0, we need to find how many 5s and how many 2s are there in that expression. And the power of 5 and power of 2 in that expression, whichever is smaller, will give us the number of zeros, right? So because we need 1 2 and 1 5 each to make 1 0. So in this case, do I have any 5 in this case? No 5s, right? So this expression will have no zeros. But this expression has a 5 here, so this can be broken down to 3 into 5. This can be broken down to 5 square. So we have three fives in this expression. So we have total 5 cube, and then we'll have to see how many 2's we have. So we have a 2 cube here, and we have a 2 here. So we have 2 raised to the power 4 in this expression. So since between 3 and 4, 3 is smaller, so we'll have 3 zeros, right? So 3 5's and 3 2's will give us 3 zeros. So this is the way to find the number of zeros in any expression. We have to count the number of 2's and number of 5's, and then whichever is lesser will be the number of zeros, right? Now we'll see another extension of this problem. So let's say we have to find how many zeros are in this expression. So the question is this: how many zeros are there in 14 factorial? So how do we go about it? So again we have to find, so that the rule holds true now also. We have to find the number of 5s and the number of 2s in this particular factorial. So we all know that this can be expanded as 14 into 13 into 12 to 11 into 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1, right? And we have to find how many 5s are there and how many 2s are there. So we have a 2 here, we have two 2s here, right? So 1 2 here, 2 2 here, 1 2 here, 3 2s here, then again 1 here, then again 2 here, and then again 1 here. So we have total 2 plus 3, 4, 7, 8, 9, 10, 11. So we have 11 2s in this case. How many 5s do we have? We have 1 5 here, we have 1 5 here, so this is 5, so we have 1 5 here, and we have 1 5 here. That's it, right? So we have 2 5s, right? So how many number of zeros this will have? So this will have 2 zeros. So whenever this will be solved, this will give us only 2 zeros, right? So this is one of the way that we can find the factorial. We can expand that factorial and then count the number of 5s and 2s individually. But this is not always feasible or optimal. Let's say our next example is we have to find it in 26 factorial. So now you won't be able to expand it, right? It will be a very tedious task, and then counting all the 5s and 2s is very difficult. One more important thing that we would want to consider while solving is that while we are solving the factorial related problems, we only need to count the number of 5s, because the number of 2s will always be greater than number of 5s in a factorial situation, right? You can see it here. When we reach 5, we reach a 5 in an interval of 5, and in that we have two even numbers, and all of those even numbers will have at least one 2, right? So we don't need to count the number of 2s, we can just count the number of 5s, and then that will give us the number of 0, right? So the question can be formed in various ways. Like the question can be formed as find the number of zeros, or the question can be that what is the highest power of 5 that divides 126 factorial, right? So in both of these cases, we we have to find the number of 5s in this expression, right? So that will also give us the number of 0, and that will also give us the highest power of 5 that divides 126, because when we say that the number of 5s, that we are meaning the power of 5, right? So that will also give us the answer to this question. So how do we find number of 5s in this particular expression? So if I do 126 by 5, I know that these many 5s will definitely be there in 126 factorial, right? Because for example, if I take 10 factorial, it is 1 into 2 into 3 into 4 into 5 up to 10, right? So the first 5 I will get at an interval of 5, and then the next 5 I will get at an interval of 5 again, right? So it is at a gap of 5. So to get how many such 5s are there, we are essentially finding the number of such intervals, right? So this will give us the number of such intervals, which is, so this we have to lower bound it, so because we have to find the integer. So this is 25, right? But is this the number of fives? No, because when we get at 25, it is not only one five, but it is two fives. Similarly, 50 is 2 5, 75 is 2 5, 100 is 2 5, right? So any multiplier of 25, which is 5 square, will give us two fives, and that will add an extra power to 5, right? Because 1 we have already counted for, so in this 25, 1 5 we have already counted for in this case, but the another 5 that we are getting in these intervals will give us one extra 5, right? So we also have to do 126 upon 25 to get those extra fives, which is 5. Also, 125 has three fives, so 2 we have already taken care of with this 5 at 25, but it still has one 5 which is not counted yet. So we have to again do 126 upon 125, which is only 1. So how many fives are there in this particular expression? It's 25 plus 5 plus 1, which is 31. So this expression will have 31 zeros, right? So generally, if we generalize this formula, if we are given a number, let's say we have given a number a factorial, and we have to find the power of any number, any prime number b in this particular expression. So right now our b was 5 because we wanted to count the number of 0, and that eventually means counting the number of fives, right? So if we wanted to count the number of fives, we approached this we did this approach. So similarly, if we generalize this, if we have a number a factorial, and we have to find the maximum power of b that divides a factorial, we can generalize that by, first we can divide a by b plus a by b square plus a by b cube plus a by b raised to the power n, until we get a integral solution, right? Until it doesn't become 0. So in this case, we if we further uh, divided it with 625, it would become 0, right? Because we are uh, rounding rounding it downwards, so that would become 0, and then we would stop. So in this case, we'll stop, and then we'll add all of these things, and that will give us the number of the maximum power of b that will divide a factorial, right? So the question can be like, just let me clear this thing. So again, the question can be that you are given 81 factorial, and you have to find maximum power of 7 that divides it, right? So again, what we need to do, we need to count sevens in 81, right? And that will give the maximum power that will divide this, right? So again, we first have to find the how many interval of sevens we have in this number, right? In this factorial. So that would give us, so we have to find the integers. So that will give us 11, right? Then we have to find how many 7 squares are in this factorial, which is only 1. Do we have any 7 cubes in this factorial? No. So the maximum power of 7 will be 12. So 12 will be our answer. But let's say if I have to find, if I uh, all these things that we are so when I told you that if I need to find power of b in a factorial, maximum power of b, this b has to be a prime number, right? We cannot do this the same approach for a non-prime number, because any factorization that we do for a particular number, it is always in terms of prime, and we always do. So the 5 was a prime, 2 was a prime, so we need to calculate the we need to divide or decompose the number uh, as at the most basic level, which will always be the prime factorization, right? So and that will only give us the powers of a particular prime in that particular factorial. So suppose we have to find the number of, so what is the highest power of 42 that divides 122 factorial? So would we be able to apply this particular formula? So if we do this, we only get 42 is, this will be 2, this will be 0. So it says that we only have uh, the maximum power of 42 is 2, which is not the case because this is not a prime number, so we cannot apply this thing. Let's break this 42 into its prime factorization, which is 2 into 3 into 7, right? Now we have to find that how many 2's, 3's or 7's are in this number, and the max minimum of those, right? So the minimum power will be of 7 among these. So we have to find the minimum, because we need, again we need, like 10 we had 2 into 5. In this case we are looking for a combination of two numbers or three numbers, in this case 42. So we have to find a minimum power that will give us the number of 42's in this 122. So if you correlate it with 10, so we said that in the factorial we'll only try to find the powers of 5, because the power of 2's will always be greater than it, and that holds true for this case also, right? 7 is a bigger number, so its power in this particular number will be lesser than these two. So we just need to find the power of this in this, the maximum power, and that will give us the maximum power of 42 that divides 122. So again we have to find 122 upon 7, which is 17, 122 upon 49, which is 2, and then 122 upon 7 cube, which is 0, right? So the total number will be 17 plus 2, which is 19. So we have the maximum power of 42 is 19, which will divide 122 factorial, whereas in this case we were getting 2, which is completely wrong. So this is the correct solution, right? So I think this concept was clear to you, and you will be able to apply this in any of these scenarios where you are either asked to find the number of zeros in a particular expression or a factorial, or you have to find the maximum number of power of a prime number or non-prime number that divides a particular factorial. If you have any doubt, do let me know in the comment section. I'll try to explain it in any of my next videos. If you want to discuss any questions on these terms that you come across, do post that in the comment. Subscribe to the channel and like this video if you want to get notified for the contents that I put on a daily basis. Thank you very much for your time.